Well, hello, students. I would like to welcome you to class or recitation on Fridays um, in video format. So, first, a few things. I will be having office hours on Zoom on Tuesdays, 3 to 4, and I'll send you the Zoom contact thing for that. It'll be the same contact every week. Please contact me with questions, though. You don't need to wait till Tuesday to ask me questions. You're more than welcome to contact me through Canvas or email and ask questions at any time, and I'll try and get back to you as quickly as I can. Um, I recommend for that, just probably the quickest way to get me a question and get you an answer that you're looking for back is if you email me a picture with the original math question. And you can also email me a picture of whatever math you've done, sort of your work, and like arrows like stuck here. That makes it real fast and clear where you're stuck. I also recommend send a short comment in the email. If you just send me a picture of the math problem, then I'm just stuck sort of answering the whole problem, not knowing where you're, having trouble. And a lot of times, we're having trouble at this step. So make that clear in the email. But we can also schedule a Zoom session or email back and forth and share videos like this one just as needed. As I said, we don't have to wait till Tuesday. So please contact me. I'm here to help you, and hopefully I can do that quickly and keep your learning moving forward. Okay, for Fridays. So I will hopefully send out a reminder like Wednesday night. So if I send it out Wednesday night, then you can send me some questions or topics that you want me to review like Thursday morning, and I'll have those by Thursday afternoon, and then I'll have time to make a video by Friday morning. So I hope to have video on Canvas by 11 a.m. Friday so that you can watch it, similar to this one. And after that, I will be available from 11 to 11:30 on Zoom. And so you can ask me any other questions that come up and whatever I didn't make clear in the video. So I will be available for that. And then your quiz is available on WebAssign starting at 11:30. And just to let you know, big note, no quiz this week. So there's no quiz this week, but starting next week, your quiz will be available at 11:30. However, it is only needing to be completed by 11:59 midnight Friday. So WebAssign will give you 30 minutes to complete the quiz once you open it. So you only have 30 minutes to complete it once you open it, but you don't need to open it until 11, 29 p.m. to get your full 30 minutes. If you're one of the students who's contacted the professor about your DSP accommodations, that should already be entered into WebAssign, and so it should correctly give you the correct amount of time. If it doesn't, then please let me know. Anyway, just to keep things moving along, figured I would review a couple of problems that sort of came up in questions this week, and then I will be available in Zoom. So, let's do this here. Okay, first problem. Let's review the chain rule. Okay, so if we're given a function, let's say h of x which equals the cube root of 2x squared plus x. So my big note for this is that parentheses are your friend. I would also rewrite things as exponents, and I will personally like to just use negative exponents unless I have to simplify it otherwise. So I would just rewrite this first as 2x squared plus x to the 1/3 power. Okay, so now in order to use the chain rule, we need to write our h of x as a function f with another function g inside of it. So we can sort of see here, we clearly have an inside function and then an outside function. So our inside function we'll call g of x is 2x squared plus x, and our outside function we'll call f of u equals, all right, parentheses, u to the 1/3 power. Okay, so now the chain rule tells us to take the derivative of this, h prime, well, that's f prime with g left alone inside of it, times, and then here's where I really recommend parentheses, g prime of x multiplied. So I recommend writing these parentheses and then getting rid of them carefully if you don't need them. But to do this, we just need to basically figure out what the parts we need. We need f prime. So if f of u is u to the 1/3, then f prime of u is 1/3 u to the 1/3 minus 1 is negative 2/3. And we also need our g prime. And g prime, again, parentheses, just to really make sure I'm using it. Oops. So I need g prime, not g. Sorry. G prime is 4x plus 1. And now we actually have all the three parts we need. We have our f prime, our g, and our g prime. Now we just need to write our formula. So h prime equals f prime 1/3. And then what's plugged in the f prime? G. 2x squared plus x. Note in the formula, probably one of the biggest things that students get wrong when they're first learning this is that they plug g prime in here instead of the original g. So it's the original g left alone inside here and g prime multiplied on the outside. So that is f prime with g plugged into it times, and then parentheses, 4x plus 1. So the biggest one is that this is not equal to 1/3 2x squared plus x to a negative 2/3 times 4x plus 1. Order of operations says I'd have to do this multiplication So I'm only multiplying it times the 4x, and then I add 1. This says I multiply it times 4x plus 1. They're not the same. This one is the one that comes from the chain rule. This one we need to not do. So parentheses really are your friend, and I wrote them extra along the way, but extra parentheses probably the better way to go. Hope that helps with that one. This could be further simplified and rewritten if you need to. Okay, let's do another problem of a different sort. This one says that if f prime of, this one's not of x, it's f prime of t equals 18 over 1 plus t squared, and it wants us to find f such that f of 1 equals 4. Okay, so they gave us the derivative and one point that it goes through, and it wants us to find the original function. So the big rule for this one is that if I had a function g of x that equaled a constant a times a function f of x, then g prime equals a times f prime. So sort of the constant just kind of hangs out front and goes for a ride if I'm taking a derivative of a function that's multiplied by a constant. So let's look at where the constant is in this. 18 over 1 plus t squared can be written as 18 times 1 over 1 plus t squared. So now it looks like I have an 18 that's just going for a ride, and I've got this other function. Now, unfortunately, this is just, again, one of those ones we have to look at and memorize and know. We might have to look it up in the back of the book, but that is the derivative of arctangent. So arctangent of t prime equals 1 over 1 plus t squared. So that's just a fact we have to look up in the back of the book. But if I know that, then I can guess what's the antiderivative. I took the derivative, I want to go backwards. Antiderivative of 1 over t squared, well, it's just arctangent. But anytime I take a antiderivative, well, this wasn't just the derivative of arctangent equals this. It could have been any arctangent plus c. So the antiderivative of this is the arctangent of t plus c. And I had an 18 that went for a ride. So I have this times 18. 18 times c is just some other c. So I'm just going to leave that as c. So this equals my f, except for the fact that I have this c. And we need to plug in our point in order to solve for it. So we know that f of 1 equals 18 arctangent of 1 plus c, and that has to equal 4. So if I know the arctangent of 1, the arctangent of 1 is what angle, if I took the tangent of it, would give me 1. That's 45 degrees, or pi over 4 times 18 plus c equals 4. And solving this for c gives me that c equals 4 minus, I'm going to simplify a little bit, 9 pi over 2. So now I can write my final answer. Always best to write your final answer. Again, f of x equals 18 times the arctangent of t plus, parentheses are a friend, 4 minus 9 pi over 2. And there we go. I hope that's helpful, and I'll see you shortly.